Welcome to qnawire.
Today we'll be looking at question number 7 of chapter 1, Intro, Structure and Properties textbook. So this is question number 47. In this case, that a filled balloon is and about 1.50 grams of hydrogen reacts with 12 grams of oxygen. So the question is, let's determine grams of water vapor in this chemical. So this here is the chemical equation of the reaction that's happening. So we have hydrogen gas reacting with oxygen gas, giving us water vapor. Right? It's important to balance this chemical equation here. So I have done that. So we have 4 hydrogen gas molecules on the right-hand side of this expression, right? 2 times 4. Likewise, we have 4 hydrogen on the left-hand side. We have 2 oxygen here, and we have 2 oxygen here. So ours is balanced. So after knowing what the mass is, we need to determine what the molar mass of these species are. So the molar mass, essentially, for hydrogen gas is basically the sum of the molar mass of the hydrogen. Molar mass of the hydrogen about 1.008 grams per mole. So the molar mass of hydrogen gas would be about 2.016 grams per mole, right? And the molar mass for oxygen, I'll leave you to do that, but when you do that, you should get around 31.998 grams per mole. So that's a 9. Right, so 31.9 grams per mole. So we need to determine the moles of these species are. So you need to remember that the mole is given by the mass over the molar mass. So for the mole of hydrogen gas here, that's going to be given by the mass, which is 1.50 grams divided by the molar mass, which is about 2.016. So it's a 6. Grams per mole. And that gives us 0.744 moles. All right, so that's the mole of hydrogen gas. And the mole of oxygen gas is the same thing, same expression here, mass over molar mass. And we know what the mass is. The mass is around 12.0 grams divided by the molar mass, which is 31.998 grams per mole. And that gives us around 0.375 moles. All right, so now that we have the moles of each of these reactants, what we need to do is we need to determine which reactant is a limit, because the reactant that is the limiting reagent of this chemical reaction is going to give us the moles of the product that's going to be formed. So the limiting reagent is the minimum amount of species that reacts with the other product to give you the, sorry, that reacts with the other reactant to give you the product. So in this reaction here, if, for instance, hydrogen is the limiting reagent, we know that all of the hydrogen is going to react with the oxygen to give us water. So we can be sure that the moles of the water is similar, or is equal to, actually, to the moles of the limiting reagent, which is hydrogen. So we need to first determine what the limiting reagent is. And one easy way to do that here is to determine the amount of moles of each that react. So here we have this moles here is 2 moles of hydrogen. So when you divide this by 2, you're going to get 1 equivalence of hydrogen gas here. And dividing 0.744 by 2 gives us, so what I'm saying is, so 1 mole of this hydrogen, or equivalence of this hydrogen gas, is basically going to give us 0.372 moles of hydrogen, right? So what I'm saying is, so this is 1 equivalence. I should state that. So 1 equivalence of hydrogen gives us 0.372, and that amount of moles is less than 1 mole of the oxygen that reacts. So in this chemical equation here, we can be sure that the hydrogen is the limiting reagent in this, because 1 mole of hydrogen, right, is 0.372, whereas 1 mole of oxygen is about 0.375. Right, so 0.372 is the moles of hydrogen, right, for 1 equivalence here. And in order to determine the amount of water molecules, or the water vapor that's formed here, we're asked to find what the mass is. So the expression for the mass, all you need to do is solve for mass here. And mass is given by the expression mole times molar mass, right? So for the mass of water vapor here, we know that, remember, we have 2 moles of this, right? So 2 times this limiting reagent here, or it's the same as this, 2, right? So we can be sure that the mole of water vapor here is going to be 0.744 moles, because that's the moles of limiting reagents. That gives us our product, times the molar mass of water. The molar mass of water is 18.015 grams per mole. You should check this. You should do the math. Molar mass of oxygen plus 2 times the molar mass of hydrogen, and that gives us around 13.4 grams of water vapor. So that is our final answer. Chemical reaction, the amount of water that we is 13.4 grams.